Welcome back. This is lesson 2 on interference, and we will discuss destructive interference in this video. So, destructive interference occurs when two pulses meet to form a resultant smaller pulse. And we will look at the example on page 13. On page 13, they've got a pulse that is moving to the right, that has a positive amplitude of 10. I'm going to call it pulse X, moving to the right, and its amplitude is plus 10. The width of this pulse and the width of the next pulse must be the same. So in the same medium, there is another pulse coming or moving towards the left, and that pulse, I'll call it Y, has an amplitude of -8. So during superposition, the resultant amplitude will be a plus 10 and a -8, which gives you plus 2. So this is what they call the vector sum of the amplitudes. So the resultant amplitude during superpositioning is a plus 2. Sorry, I'm not drawing it to scale. You should be drawing it to scale, especially in an exercise here. So this is X and Y superpositioned. The width of the pulses should be the same. So when you draw them, you can be kind to yourself and use a ruler to do that. After superpositioning, pulse Y will be on the left-hand side and pulse X would be on the right-hand side. So pulse Y would carry on moving to the left without changing, and pulse X would carry on moving to the right without changing. What does that mean? It means that the amplitude of X is still plus 10 and the amplitude of Y is still -8, and that the pulse widths are the same. They haven't changed. Right, so this is a demonstration of destructive interference. Right. Another example that is not somewhere in the book at this point in time is where the pulses have exactly the same magnitude of amplitude but opposite in direction. Say pulse X and pulse Y, direction of propagation indicated by the arrows. Pulse X has a plus 10 amplitude and pulse Y has a -10 amplitude. So when these two pulses coincide, you'll see no disturbance during superpositioning because you have total destructive interference. You have no disturbance. After they have met, though, you will find that pulse Y will continue moving, to the left unchanged, and pulse X will continue moving to the right unchanged. That is very important, that the width of the pulse and the amplitudes of the pulses, or waves for that matter, will not change. Okay, this is called total destructive interference. Right. Next, I want us to go to exercise number 1.1. So it's exercise 2 on page 15, number 1.1. There is a pulse there, A, and if you count the blocks, it is 7.5 blocks up. That means the amplitude is 7.5. From the rest position, the maximum displacement. That is for pulse A, and pulse A is moving towards the right in this medium. Coming towards pulse A is a pulse B with an amplitude of -4. So the amplitude of pulse B is -4. Minus because it's going in the opposite direction to pulse A's amplitude. So pulse B moves to the left. When these two pulses meet, what will the amplitude be? The resultant amplitude will be 7.5 minus 4. We're adding two vector quantities and we get 3.5. Because the resultant pulse is less than any of the other two pulse amplitudes, this is called destructive interference. So the amplitude there is plus 3.5. This is an example where pulse A meets pulse B. They are in superposition. After they have met, pulse B would still continue moving towards the left, and pulse A will continue to move towards the right unchanged. It means that the amplitudes of these pulses would be what they were before the interference took place. So that is 7.5 amplitude, and this one is a -4 amplitude. Right. We need to go to page 16, and I've already done number 1.1, so this one is 1.2. You have two pulses there. The one has 10 blocks, goes 10 blocks up, and the other one goes 5 blocks up. I bet if you count the blocks for the width of the pulse, those widths would be the same. So when you draw this in your book, the pulse widths should be the same. And this one's amplitude is 10. And this one's amplitude is 5. So pulse A is moving to the right, pulse B is moving to the left. Now you need to fit in on there what these pulses would look like when they are in superpositioning. So you have something that goes up 15 blocks. So A plus B has an amplitude of 15. Please check when you draw the pulse width should be as the book says. Right, then after the superpositioning, pulse B would be on this side and pulse A would be on that side. They would not change during the superpositioning, so this one should have a +5 amplitude and that one should have a +10 amplitude. They swapped sides. So this is pulse A moving to the right and pulse B moving to the left. Right, I think you can try number 1.3 by yourself.